Hello, everybody. It's Mrs. Pound, and I'm here with a new chapter, chapter 27 on light. This is one of many chapters where we're going to be talking about different properties of light. So, our objectives for today are to describe the dual nature of light, explain why it is much more difficult to measure the speed of light than to measure the speed of sound, and describe the relation between light, radio waves, microwaves, and X rays. So, some early concepts of light. So, light is actually a photon. This is a particle of light. It's massless bundle of concentrated electromagnetic energy. And you're like, wait, but I thought light was a wave, not a particle. Well, it is both. It behaves in both manners. Light has a dual nature, part particle and part wave. And this is really a very strange concept, but we do observe it happening all around us in nature. So it's one of those mysteries of God. So, what about the speed of light? Well, we measure the speed of light. Actually, when we're talking about distant planets, we measure it in light years. This is the distance light travels in 1 year. And the reason we measure it that way is because the speed of light is 300,000 kilometers per second. That means it travels around the Earth 7.5 times in 1 second. That is really fast, and that is why it is difficult to actually measure the speed of light because it is so fast compared to the speed of sound, and why we measure it in light years because it does travel so fast as opposed to smaller units. Electromagnetic waves. So, an electromagnetic wave is a wave that is partly electric and partly magnetic and carries energy, and it's emitted by vibrating electric charges. So, this is what light is it is an electromagnetic wave. It's partly electric, partly magnetic, carries energy, and starts by vibrating electric charges. It is also broken up into the electromagnetic spectrum. This is the range of electromagnetic waves extending from radio waves to gamma rays. So, the types of electromagnetic waves are gamma rays, which are the highest energy over here on the left. They have the shortest wavelength and the highest frequency. And then after that are X rays and ultraviolet rays. And because of this high energy, these can be very damaging to us, okay? Ultraviolet, X rays, gamma rays can cause cancer. Now we look towards, I guess, the middle here. It's shown as the middle here. Visible light. This is what we can see. We can actually see a very small part of the spectrum. After that is infrared, microwaves, and radio waves. So infrared is heat. Microwaves we use for our food and also for communications. Infrared is also what your remote control uses at home. And radio waves we use for communication with television, walkie-talkies, um, radios that we listen to, that sort of thing. And as we go to the right, we have less energy, longer wavelengths, lower frequency. So these on the right are not as damaging to us, although too much heat and you can get a burn. Okay, so that's the electromagnetic spectrum. Now, infrared, right here, right after the visible spectrum or on one side of it, these are EM waves of frequency lower than the red of visible light. And as I said, they tend to be heat. Ultraviolet are electromagnetic waves of frequency higher than those of violet light. And this is what causes skin cancer in us. Now, visible light, as I had pointed out earlier, is a very small part of the electromagnetic spectrum. It is actually less than 0.1% of the electromagnetic spectrum. So we cannot see most of this spectrum, only a very small portion of it. Now, other creatures can see more or less on each side. Heat lamps mostly give off infrared. That is what they are using when you see a heat lamp. And another thing to know, and you can see it here in the diagram, is electromagnetic waves are transverse waves. Another thing to know is light can travel in a vacuum, it can travel in space. It does not require a medium. And we'll talk more about that when we talk about electricity and magnetism. And let's compare that to sound real fast. Remember, sound is not an electromagnetic wave. It is a longitudinal wave and must travel through a medium, unlike light. Sometimes people get sound and radio waves mixed up, and so they think that sound is an electromagnetic wave because we use radio waves to be able to hear things. But they are very different. Radio waves travel at the speed of light. Sound travels at the speed of sound and is an entirely different kind of wave. We just use radio waves to transmit signals very quickly from place to place and then convert it back to sound. Okay, so there is a conversion there between two different types of energy. They are not the same thing when we are using walkie talkies. So our objective was to describe the dual nature of light, to know that it behaves like a particle and like a wave. And those particles are called photons. To explain why it is much more difficult to measure the speed of light than to measure the speed of sound because it's just so much faster. And to describe the relation between light, radio waves, microwaves, and X rays, the fact that they are all electromagnetic waves, they all travel at the speed of light. They just have different wavelengths, frequencies, and energies. So don't forget your 5 questions, and I will be back with more about light.